Myself, I am Tony CJ, working as an assistant professor in the Department of Physics, Jyoti Engineering College, Cheruthuradi. Today we are going to discuss some basic concept of laser. First topic is population inversion. The number of atoms per unit volume of a lasing medium at an energy state is known as population of that energy level. That means generally we will have two energy states. One is ground state and second one is excited state. Okay, so the number of atoms in the particular ground state or excited state, that is known as a population of that particular energy level. Okay, now if n1 and n2 are the number of atoms in the ground level of energy E1 and in the excited level of energy E2, that means if suppose I already told we will have two energy level, one is ground state and second one is excited state. Suppose n1 is the number of atoms in the ground state having energy E1, okay, and excited level having the number of atoms n2 and energy E2, then they are these two energy levels and these two number of atoms then can be related by a relation which is given by n2 is equal to n1 e raised to minus e2 minus e1 divided by kt, where k is the Boltzmann constant and T is the temperature in absolute scale. At a normal temperature T, n1 far greater than n2. Okay, here we can conclude that the number of atoms in the ground level that should be higher than number of atoms in the excited level. That is, in generally, or we can say that in normal temperature, the number of atoms in the ground level that is mostly populated or densely populated than excited level. So here this is the normal condition. Now we will come to the topic population inversion. Okay, the situation in which the number of atoms in the higher energy state is made larger than that of lower energy state. That means if number of, I already told you, in general cases the number of atoms in the ground level will be more than excited level. Now what do you mean by population inversion? Just inversion of that phenomena. That means if number of atoms in the higher energy state if larger than number of atoms in the lower energy state, that is known as a population inversion, that is n2 far greater than n1. Okay, so for basic phenomena of the lasing action is the population inversion. So we should know what is the population inversion. That is, in general, in ground state is mostly populated than excited level, that is n1 greater than n2. Population inversion, just inversion of this phenomena, that means n2 far greater than n1. So this is the population inversion. Now we will go to the metastable state. So as I already said, we have two energy state, one is ground state and second one is excited level. Suppose now if an atom in the ground state has got some energy from external source and it will go to the excited level. Okay, in excited level generally 10 raised to minus 8 seconds the atoms will reside. After that these atoms will lose some amount of energy that can be in the form of heat energy or light energy or any other form of energy or vibrational energy, and it will come back to the ground state. Okay, so here in order to make it the lasing action, we will have only two energy levels. Okay, an atom with two energy levels cannot produce population inversion, but in order to achieve the population inversion we cannot achieve with the two energy levels. Here this is the situation that metastable state. So in order to achieve the population inversion, the system should have at least three energy levels. Generally we will have ground state energy level and excited energy levels, but for the lasing action should be takes place, we will have three energy levels. That means we will have some energy state which should have more lifetime. Here in general we will have the lifetime of atoms. Lifetime means the time that resides the atoms in the particular energy levels. Here, as I already said, in the excited cells generally 10 raised to minus 8 seconds the atoms will reside. Okay, so this is a very short interval of time. So now we are imagine a third state, that is metastable state, which should have more lifetime in the sense the time duration the atoms will reside particular energy level. Okay, so in order to achieve population inversion, the system should have at least 3 energy levels. Here comes the importance of metastable state. Among 3 energy levels, one energy level should have longer lifetime. Okay, such an energy level is known as a metastable state. So now we are having the 3 energy levels. One is ground state and second one is excited state. In excited state, number of atoms will reside for 10 raised to minus 8 seconds. Okay, now here comes the third state, that is the metastable state, or we can say that as an intermediate state. Okay, here the lifetime of atoms delta T, that in the particular energy level, that is related by the width of the energy level delta E, which is given by the uncertainty relation, as I already mentioned in the previous chapter, that is delta E into delta T equal to H, where H is the Planck's constant. So this is the metastable state. So we can say that this is an intermediate energy state having lifetime is more. Here lifetime will come around 10 raised to minus 3 seconds. So that is the importance of metastable state. So the intermediate energy level between the excited level and ground level and having narrow bandwidth will comparatively larger mean lifetime. Such an intermediate energy level is known as a metastable state. The atoms will reside in the energy level sufficiently longer time. As I already told, that in excited level, the time duration or lifetime, the lifetime of the atoms will be 10 raised to minus seconds. But in excited level, the lifetime of the atoms is 10 raised to minus 3 seconds, which helps to to achieve the population inversion. So in order to achieve the population inversion, we should have 3 energy levels. So one is ground state and second one is excited level and third one is metastable state, that is an intermediate energy state. So within that time duration, or we can say that the lifetime, within this lifetime, the population inversion can be achieved. The lasing transition by stimulated emission takes place between the metastable. Actually, the lasing transition means actually we have one is ground state to excited level transition, then excited level to metastable state transition, then metastable state to ground level transition. So actually the lasing transition by stimulated emission takes place between the metastable state and a lower energy level. Okay, hence the metastable level is known as a upper lasing level. Okay.